Hello students, today we will be solving Pure Maths Paper 1 from October-November 2016, Variant 3. Question number 1. Find the set of values of k for which the curve y equals to kx squared minus 3x and the line y is equals to x minus k do not meet. So for this, we need to think of the discriminant must be less than 0. And so before doing that, we need to equate these two equations. So it will be kx square minus 3x equals to x minus k. So kx square minus 3x minus x plus k is equals to 0. So kx square minus 4x plus k is equals to 0. Now comparing this with the quadratic equation, which is ax square plus bx plus c, that gives us a must be k and b must be negative 4 and c must be k. Now let's substitute this into this equation. That will give us negative 4 whole square minus 4 times k less than 0, which is 16 minus 4k square less than 0. So negative 4k square is less than negative 16. Now let's multiply both sides with negative 1. That gives us 4k square is greater than 16. By multiplying both sides with negative 1, the sign of the inequality flips. So k square is greater than 4. So k square minus 4 is greater than 0, or we can say k square minus 2 square is greater than 0. Then we are using the formula a square minus b square is a plus b and a minus b. So for this, it becomes k plus 2 and k minus 2. So the critical values are k is equal to negative 2 and k is equal to positive 2. With the help of the number line, and for the equation to be greater than 0, k must be less than negative 2 and k must be greater than positive 2. Question number 2. The coefficient of x cubed in the expansion of 1 minus 3x to the power 6 plus 1 plus ax to the power 5 is 100. We need to find the value of the constant a. So let's find the coefficient of x cubed, and this is very easy because we can see that x is on this side. That means we can use the formula 6c3 because this 3 will become the power of negative 3x. So 6c3 times 1 to the power 6 minus 3 times negative 3x whole to the power 3, which gives us 20 times 1 times negative 27x cubed, which is negative 540x cubed. And the coefficient of x cubed for this expansion will also be 5c3 because this 3 will become the power of ax. So 5c3 times 1 to the power 5 minus 3 times ax to the power 3 is equals to 10 times 1 times a cube x cube, which is 10a cube x cube. Now it's given in the question that the coefficient of x cube for this expansion is 100. So we can say negative 540 plus 10a cube, when you sum them, it will be equal to 100. So 10a cube must be 640. So a cube is 64, therefore a is 4. Question number 3. Showing all necessary working, solve the equation 6 sine square x minus 5 cos square x equals 2 sine square x plus cos square x for x lies between 0 and 360. So this is the equation that we have. Now we can manipulate the cos square x as 1 minus sine square x. So my objective is to express the whole equation in terms of sine square x. So 6 sine square x minus 5 times 1 minus sine square x equals 2 sine square x plus 1 minus sine square x. Simplifying this, we get 6 sine square x minus 5 plus 5 sine square x is equal to 2 sine square x plus 1 minus sine square x. Or we can say 11 sine square x minus 5 is equals to sine square x plus 1. So 10 sine square x is equals to 6. Therefore, sine square x is 0.6. So sine x will be plus minus square root of 0.6. Now let's find the basic angle. Basic angle has to be sine inverse of positive square root of 0.6, which gives us 50.768. Now When sine is positive, it lies in the first and the second quadrant. And the limit that we were provided with was x lies between 0 and 360 inclusive. That means we can take both of these quadrants. So for the first quadrant, the basic angle will be the actual angle, which is 50.8 in three significant figures. And for the second quadrant, it will be 180 minus the basic angle, which is 129.2. Now, when sine is negative, it lies in the third and fourth quadrant. Again, our limit is between 0 and 360. That means we can take both of these quadrants. So for the third quadrant, it will be 180 plus the basic angle, which is 230.8. And for the fourth quadrant, it will be 360 minus the basic angle, which is 309.2. So the angles are all four of them. Question number 4. The function f is such that fx is equal to x cubed minus 3x squared minus 9x plus 2 for x is greater than n, where n is an integer. It is given that f is an increasing function. We need to find the least possible value of n. So this was the function, and when they're talking about the increasing function, that means we need to differentiate it. So differentiating, we get 3x squared, x cubed becomes 3x squared, and 2 times 3 is 6, 2 minus 1 is 1, so 6x, and negative 9x will become just negative 9, plus 2 becomes 0. For increasing function, it has to be greater than 0. So 3x squared minus 6x minus 9 is greater than 0. We can divide both sides with positive 3 and it becomes x squared minus 2x minus 3 greater than 0. Next we do middle term break and it gives us x squared minus 3x plus x minus 3 is greater than 0. If we take x common, it becomes x minus 3 within brackets, and if we take plus 1 common, we get again x minus 3 greater than 0. So the factors are x plus 1 and x minus 3 greater than 0. Therefore, the critical values are x is negative 1 and x is positive 3. Now, since the quadratic equation is positive, it will be a U shape, and we have the critical values at negative 1 and positive 3. Now, for this equation to be greater than 0, x must be less than negative 1 and x must be greater than 3. But since it was given in the question that x is greater than n only, that means we have to discard this option and we need to choose x greater than 3 only. So x greater than n means x greater than 3. Therefore, n is equal to 3. Question number 5. The diagram shows a major arc AB. So this is the major arc AB with center O and radius 6 centimeter. This is also radius 6, 6, and this is also 6. Points C and D on OA, these are the points on OA and OB respectively, are such that the line AB is a tangent at E. The line AB is a tangent at this point E. To the arc CED, this is the arc CED, of a smaller circle also with center O. Angle COD, this angle is 1.8 radians. We need to show that the radius of the arc CED, this arc, is 3.73 centimeter, correct to three significant figures. So in order to solve this, what we can do is consider the triangle OBE. So we are considering the triangle OBE, this triangle. So BOE, this angle BOE, is 0.9 radians because I'm bisecting the line AB with OE. So OB is 6. OB is also 6 because that is the radius as well. OE is equal to radius of CED. OE is the radius of, so I'm talking about this smaller circle. So OE is equals to 6 cos 0.9. So if I extract this portion of the diagram, the triangle OBE, 6 is the hypotenuse and 0.9 is the angle. So we can say cos 0.9 is adjacent over hypotenuse, which is OE over 6. So OE is equals to 6 cos 0.9. So we can write this directly, because when we have the angle and the hypotenuse and we are finding the adjacent side of the angle, it will be 6 cos 0.9. So that gives us OA is equals to 3.73. In the second part of the question, we need to find the area of the shaded region. So basically we need to find the area of the whole thing. So we have to find this area plus the area of this sector as well. So area of the major sector, for which the radius was 6, we are using the formula half r squared theta. We knew the angle COD is 1.8. That means the angle on the other side, the reflex angle, must be 2 pi minus 1.8. So the area must be half times 6 squared times 2 pi minus 1.8. That gives us 80.7. And the area of the minor sector is half times this radius whole square times 1.8, which is the angle COD. So that gives us 12.52. So the required area must be this plus this, which gives us 93.22. Question number 6. The 3 points A, B, C are such that B is the midpoint of AC. The coordinates of A are 2m and the coordinates of B are n and minus 6, where m and n are constants. Find the coordinates of C in terms of m and n. So let's consider the coordinate of C as xy. Since we are provided with the coordinate of A and B, and it says that B is the midpoint of AC, that means 2 plus x over 2 must be equal to n, because that is the midpoint. And xy are the coordinates I'm considering for the coordinate of C. So 2 plus x over 2 is equals to n. Similarly, m plus y over 2 is negative 6, because again B is the midpoint of AC. So the equations, when we simplify them, it becomes 2 plus x equals to 2n. So x is equals to 2n minus 2, and m plus y is equals to negative 12. So y is equals to negative 12 minus m. So we have expressed the coordinates of C in terms of m and n. In the next part of the question, it says the line y equals to x plus 1 passes through C and is perpendicular to AB. So the line passes through C and is perpendicular to AB. We need to find the values of m and n. Let's proceed with the information that has been provided. So gradient of AB is minus 6 minus m over n minus 2. So the formula we used to find the gradient was y2 minus y1 over x2 minus x1. So minus 6 minus m over n minus 2. Or we can take negative common and it becomes m plus 6 over n minus 2. Gradient of AB is perpendicular to the line y equals to x plus 1. So the gradient of this equation must be 1. The coefficient of x is 1, which means the gradient of this line is 1. Now, since the gradient of AB is perpendicular to this line, that means the gradient of AB must be negative reciprocal of this 1. So it will be minus 1 over 1, which is minus 1. So we can say minus within brackets m plus 6 over n minus 2 is equal to negative 1. So m plus 6 over n minus 2 is equals to 1, because we are multiplying both sides with negative 1. So m plus 6 is equals to n minus 2. So m is equals to n minus 8. Let's call this equation 1. C lies on the line y equals to x plus 1, and it is stated in the question. So minus 12 minus m is equals to 2n minus 2 plus 1. So this is the coordinate we have found earlier, that the y coordinate of c is minus 12 minus m and the x coordinate of c was 2n minus 2. So we are substituting the coordinates of c into this equation, which gives us this. So negative 12 negative m is equal to 2n minus 2 plus 1. So minus 12 minus m is equals to 2n minus 1. So minus 11 is equals to m plus 2n. Therefore, m is equals to minus 2n minus 11. And let's call this equation 2. Now, using the equation 1 and equation 2, if we substitute, we get n minus 8 is equal to minus 2n minus 11. Therefore, 3n is equals to negative 3. So n must be negative 1. Now, if we substitute negative 1 in any of this equation, we will get m is equals to negative 9. Question number 7. It's not in the syllabus at the moment. Question number 8. Express 4x squared plus 12x plus 10 in the form ax plus b whole square plus c, where a, b, and c are constants. So this is the completed square form. So for that, first we need to take 4 common, and that makes it x squared plus 3x, and let's keep the 10 outside, so it is positive 10. Now we will be doing the completed square form just for this bit. So keeping 4 outside, this becomes x plus 3 over 2 whole square minus 3 over 2 whole square plus 10. So this becomes x plus 3 by 2 whole square minus 9 by 4. If we take away the brackets, we get 4 times x plus 3 by 2 whole square minus 9 plus 10. Simplifying this further, we get 4 times x plus 3 by 2 whole square plus 1. Or we can say this is a square number, so it is 2 square times x plus 3 over 2 whole square plus 1. Now since this has a power of 2 and also this has a power of 2, we can multiply 2 with the elements within the bracket. So it will be 2 times x, which is 2x, plus 2 times 3 over 2 is 3. So it will be 2x plus 3 whole square plus 1. So we have just expressed this in this format. So you have to look very closely that a was not outside, a was inside. Therefore, it will be ax plus b whole square. For that, we have converted 4 into 2 square and simplified it like this. And this is our final answer. In the next part of the question, functions f and g are both defined for x greater than 0. It's given that fx is x squared plus 1 and the composite function f(g(x) is 4x squared plus 12x plus 10. We need to find gx. So over here in this question, we are already provided with the composite function. We need to find gx. That means it's a reverse working type of question. So if fx is x squared plus 1, fg of x is 4x squared plus 12x plus 10, we have done completing square for this equation, which came down to 2x plus 3 whole square plus 1 in the previous part. And if you look closely, the whole bracket square plus 1 is related to x squared plus 1. So we can say that gx must be 2x plus 3, because when 2x plus 3 is substituted in this equation, it becomes 2x plus 3 whole square plus 1, which is the same as 4x squared plus 12x plus 10. Therefore, g of x must be 2x plus 3. In the next part of the question, we need to find the inverse of fgx and give the domain of the inverse. So let's consider y is equals to fg of x. So y is equals to 4x squared plus 12x plus 10. So y is equals to 2x plus 3 whole square plus 1. And you should remember that you will not be able to find the inverse if your original equation is a quadratic equation. You always have to do the completed square form first. So 2x plus 3 whole square is equals to y minus 1. So 2x plus 3 is equals to plus minus square root of y minus 1. Therefore, 2x is equals to negative 3 plus minus square root of y minus 1. So x is equals to minus 3 plus minus square root of y minus 1 over 2. If y is equals to fg of x, that means fg inverse of y is equals to x. So fg inverse of y is equals to minus 3 plus minus square root of y minus 1 over 2. So fg inverse of x is equals to minus 3 plus minus square root of x minus 1 over 2. Or we can say fg inverse of x is equals to minus 3 by 2 plus minus square root of x minus 1 over 2. Now, before finalizing whether it will be plus or minus, we have to figure out something first. So fg of x is equals to 2x plus 3 whole square plus 1. And we can also write it as 2 square x plus 3 over 2 whole square plus 1. So the turning point is at negative 3 over 2 and 1. Negative 3 over 2 is this point. So if we consider this sketch, and it's a positive quadratic equation, so the shape of the curve must be like this, and the turning point must lie at negative 1.5 and 1. Now, previously in the question it stated that x is greater than 0. So if x is greater than 0, that means if we keep negative, it will go towards the negative side of the number line. So we have to consider the positive. So fg inverse of x is equal to negative 3 over 2 plus square root of x minus 1 over 2. Now for the domain of fg inverse of x is equals to range of fg of x. So we need to find the range of fg of x. That will help us to get the domain of the inverse. So fg of x is this. When we substitute x equals to 0, because that is from where the graph starts according to the question, we get fg of x is 10. So you can see 10 must be here. So the range, since it's a positive quadratic equation, the shape of the graph is like this, U shape, and it starts from 10 and it goes above. So the range must be, for fg of x, it will be greater than 10. Therefore, the domain of fg of inverse of x must be x greater than 10. Question number 9. Two convergent geometric progressions P and Q have the same sum to infinity. The first and second terms of P are 6 and 6R respectively. The first and second terms of Q are 12 and negative 12R respectively. Find the value of the common sum to infinity. So from the question we got that geometric progression of P, the first term is 6 and the second term is 6R. For the geometric progression of Q, the first term is 12 and the second term is negative 12R. So R has to be 6R over 6. 6R over A gives you 6R over 6. And for this, the common ratio R is minus 12R over A, which is minus 12R over 12. So that gives me R is equals to R and R is equals to negative R. So the sum to infinity for this geometric progression is A over 1 minus R, which is 6 over 1 minus R. And for this, again the formula is A over 1 minus R, so it will be 12 over 1 minus minus R, which is plus R. Now, according to the question, these two sum to infinity are equal. That means 6 plus 6R, if you cross multiply, you get 6 plus 6R is equals to 12 minus 12R. So 18R is equals to 6, therefore R is equals to 1 over 3. So the sum to infinity is 6 over 1 minus 1 by 3, which is equals to 9. Even if you substitute this value of r into this equation, you will still get the answer 9. So you can choose any of them. In the next part of the question, the first term of an arithmetic progression is cos theta, and the second term is cos theta plus sine squared theta, where theta lies between 0 and pi. The sum of the first 13 terms is 52. We need to find the possible values of theta. So A is cos theta, and since we are talking about arithmetic progression, that means the next term should be A plus D, so which is cos theta plus sine squared theta, that is the second term. So D must be, in order to find the common difference, we have to take away the first term from the second term. So it will be cos theta plus sine squared theta minus cos theta, which gives us sine squared theta. Also, it's given that the sum of the first 13 terms, that means S13 is equals to 52. Now, with the help of the formula for the sum of terms, which is n over 2 times 2a plus n minus 1 into d, so that will be 13 over 2 times 2a, which is this, plus n minus 1, which is 13 minus 1, times d is sine squared theta, must be equal to 52. Simplifying this, we get 13 times 2 cos theta plus 12 sine squared theta is equals to 2 times 52 is 104. So 26 cos theta plus 156 sine squared theta is equals to 104. So now, if we divide both sides of the equation by positive 26, we get cos theta plus 6 sine squared theta equals to 4. So 6 sine squared theta plus cos theta minus 4 is equals to 0. Or we can manipulate this, and this becomes 6 times 1 minus cos squared theta plus cos theta minus 4 is equals to 0, which gives us 6 minus 6 cos squared theta plus cos theta minus 4 is equals to 0, which is minus 6 cos squared theta plus cos theta plus 2 is equals to 0. Now, if we multiply both sides with negative 1, we get 6 cos squared theta minus cos theta minus 2 is equals to 0. Now, let's consider cos theta to be x, because we can recognize that this is a quadratic equation and it will be easier for us to solve if we simply substitute cos theta as x. So 6x squared minus x minus 2 is equals to 0. If we do middle term break, we get 6x squared minus 4x plus 3x minus 2 is equals to 0. If we take 2x common, we get 3x minus 2, and if we take positive 1 common, we get 3x minus 2 again. So the factors are 2x plus 1 and 3x minus 2 equals to 0. So x is equal to negative half and x is equals to 2 over 3. That means cos theta is equals to negative half and cos theta is equals to 2 over 3. Now let's find the basic angle. The basic angle must be cos inverse of positive half, and that gives us pi over 3. And for this, the basic angle is cos inverse of 2 over 3, which gives us 0.8411. We must be keeping our values in radians because the limit that has been provided in the question is in radians, and theta lies between 0 and pi. So which means theta lies between 0 and 180 degrees. So now let's consider what happens when cos is negative. Cos is negative in the second and third quadrant. But since the limit is between 0 and 180, which is pi, that means we can take only the second quadrant. So that means it will be, for the value of the second quadrant, it will be pi minus the basic angle, which gives us 2.09. And when cos is positive, it lies in the first and the fourth quadrant. But since our limit is between 0 and pi, that means we can only take the first quadrant. And the value for the first quadrant is the basic angle will be the actual angle. So theta is 0.84. So these are the two values for this question. Question number 10. A curve is such that dy over dx is equals to 2 over ax to the power negative half plus ax to the power negative 3 over 2, where a is a positive constant. The point A, which is a square and 3, lies on the curve. We need to find in terms of A the equation of the tangent to the curve at A, simplifying our answer. So we are provided with dy over dx, and let's substitute the value of x into this equation because it lies on this curve. That way we get, simplifying this, we get 2 over a square plus 1 over a square equals to 3 over a square. So by substituting a square into this equation, we get 2 over a square plus 1 over a square, which is the same as 3 over a square. Now we have the gradient, and we also have a point which lies on the curve, and this is the same point where the tangent occurs. So for the equation of the tangent, which is a line, we need a point and the gradient, and we have them both in terms of a. So the equation that we will be using is y minus y1 over y minus y1 is equals to m x minus x1. So it will be y minus 3 equals 3 over a square, which is the gradient, times x minus a square. That gives us y minus 3 is equals to 3 over a square x minus 3. So y is equals to 3 over a square times x. And that is the equation of the tangent. In the next part of the question, we are required to find the equation of the curve. So in the question, we were provided with dy over dx. That means we need to find y. That means we have to integrate this equation. So minus half plus 1 is positive half. So positive half times 2 over a. Sorry, minus half plus 1 is positive half, and we need to divide half. We need to divide 2 by half. That gives us 4 over a x to the power positive half. And minus 3 over 2 plus 1 gives us negative half. So ax over negative half is basically negative 2a x to the power negative half plus c. So at a, this must satisfy the equation of the curve because the point a lies on the curve. So we can substitute this into this equation and find the value of the constant c. So it will be 3 is equals to 4 over a squared to the power half minus 2a squared to the power negative half plus c. So 3 is equals to 4 minus 2 plus c, therefore c is equals to 1. So the equation of the curve must be y is equals to 4 over a x to the power half minus 2a x to the power negative half plus 1. In the next part, it says it is now given that b is 16 and 8, which also lies on the curve. We need to find the value of a. Using this value, we need to find the distance ab. So y is equals to 4 over a x to the power half minus 2a x to the power negative half plus 1. Since this lies on the curve, we can substitute this coordinate into this equation, and we get 8 is equals to 4 over a times 16 to the power half minus 2a times 16 to the power negative half plus 1. Simplifying this, we get 8 is equals to 16 over a minus a over 2 plus 1. Now, if we do LCM, we get 2a, and this becomes 32 minus a square plus 2a equals to 8. So 16a is equals to 32 minus a square plus 2a, or we can say a square plus 16a minus 2a minus 32 is equals to 0. So a square plus 14a minus 32 is equals to 0. If we do middle term break, we get a square plus 16a minus 2a minus 32 is equals to 0. If we take a common, we get a plus 16, and if we take negative 2 common, we get a plus 16 again. So the factors are a minus 2 and a plus 16. Therefore, a is 2 and a is negative 16. But in the question, it stated that a is a positive constant. Therefore, we need to discard this value, and we can only keep a is equals to 2. Therefore, the a coordinate is 4 and 3. The reason why this is 4 and 3, because point A was a square and 3, and we got the value of a as 2. So 2 square is 4, so it will be 4 and 3. So now we know the coordinate of a, and we are already provided with the coordinate of b. So it is easier for us to find the distance now. The distance will be, the formula we are using is square root of x2 minus x1 whole square plus y2 minus y1 whole square. That gives us 16 minus 4 whole square plus 8 minus 3 whole square, which is 144 plus 25. That gives us square root of 169, which is 13. Question number 11. A curve has equation y is equals to kx minus 3 whole to the power negative 1 plus kx minus 3, where k is a non-zero constant. We need to find the x coordinates of the stationary points in terms of k and determine the nature of each stationary point, justifying our answers. So this is the equation. So we need to differentiate it first because they're talking about the stationary points. That gives us an idea to that we have to find the differentiation of this equation. So dy over dx will be minus 1 times positive 1 is negative 1, kx minus 3 to the power negative 1 and negative 1 is negative 2. Then we do inside differentiation, that gives us k plus kx minus 3 will just become k, or we can write it as minus k over kx minus 3 to the power 2 plus k. At stationary point, dy by dx is equals to 0. That means this equation must be equal to 0. So if we do LCM and then we cross multiply kx minus 3 whole square with 0, we get k times kx minus 3 whole square minus k is equals to 0. If we take k common, we get kx minus 3 whole square minus 1 within brackets. That means this equation must be equal to 0 and k must be equals to 0. Also, we can say kx minus 3 whole square is equals to 1. Therefore, kx minus 3 is equals to plus minus 1. And when we consider this to be positive 1, it will be kx minus 3 equals to 1. So kx equals to 4. Therefore, x equals to 4 over k. And when we consider this to be negative 1, it will be kx minus 3 is negative 1. So kx equals to 2. Therefore, x is equals to 2 over k. Now, we need to remember that k is a non-zero constant. So we will not be considering this as a value. We will discard it and we will move on with finding the nature of each of the stationary point. So the x coordinates were 4 over k and 2 over k. So let's first find the second derivative because that will help us to find the nature of the stationary point. So if dy by dx is this, that means the second derivative will be k becomes 0 and minus 2 times minus k is positive 2k. Then we have kx minus 3 to the power minus 2 minus 1 is minus 3, and then inside differentiation gives us k. So it will be 2k square over kx minus 3 whole cube. When x is 4 over k, let's substitute this into the second derivative. Then we get 2k square over k times 4 over k minus 3 whole cube. Simplifying this, we get 2k square. And since k is a non-zero constant, that means this will be greater than 0. Hence, when x is 4 over k, the point is a minimum point. And when x is 2 over k, let's substitute this back into the second derivative. That gives us 2k square over k times 2k minus 3 whole cube, which gives us negative 2k square. So this is less than 0. Hence, this is a maximum point. In the second part of the question, the diagram shows part of the curve for the case where k is equals to 1. Showing all necessary working, we need to find the volume obtained when the region between the curve and the x-axis and the y-axis and also the line x equals to 2 shown shaded in the diagram is rotated 360 degree about the x-axis. So in such questions, you have to be very careful about the rotation, and it's getting rotated about x-axis. Sometimes it gets rotated about y-axis. So for this, in order to find the volume, eventually we will be using the formula pi integral y square dx. So let's solve it step by step. The equation of the curve is this, y is equals to this. So let's first find y square. That means we have to square the whole thing. And I'm using the formula a plus b whole square. So that gives us x minus 3 whole to the power negative 1 whole to the power square. plus 2 times a times b plus x minus 3 whole square. That gives us x minus 3 to the power negative 2 plus 2, because x minus 3, when you bring this to the denominator, this stays in the numerator, they cancel out and it becomes just positive 2 plus x minus 3 whole square. Now we have the y square. Now let's integrate this equation. So integrating this equation, we will get, so we have power as the operator. So since we have, if we differentiate this, we get 1, so we don't have to do anything with it. Now let's integrate the operator. It will be minus 2 plus 1, which is minus 1, times 1 over minus 1, because we got the power minus 1, plus 2 becomes 2x, plus, since power is the operator, we need to differentiate this. We get, when we differentiate this, we get 1, so we don't have to do anything with it. And x minus 3, 2 plus 1, the power becomes 2 plus 1, which is 3, and we have to multiply it with the 1 over this power, which is 3, plus c. So simplifying this, we get minus x minus 3 whole to the power negative 1 plus 2x plus 1/3 of x minus 3 whole cube plus c. Now since we are talking about the volume, we can ignore c for this equation, and the required volume must be within the limits of 2 and 0. So we have already done the integration, so simply we have to put the limits into this equation. So substituting the value of 2 into this equation, we get 14 over 3, and substituting 0, we get 26 over 3. And the formula was pi integral y squared dx. After multiplying pi with the simplified value of this, we get 40 pi over 3, which is the same as 41.9. And that will be all for now. I will see you in the next video.